Greetings and welcome to the video where we're going to introduce the concept of effect size. And so let me just kind of get our title up here, effect size. Well, I guess a good place to start here, if we're just going to introduce the topic, is really to give a kind of just a general definition here. Our general definition is that an effect size is just a value, not unlike the t value that we were calculating when we were doing inferential statistics on one sample, dependent sample, and independent sample t-test. An effect size is a value which reflects the magnitude of the treatment effect. Remember, the treatment is your independent variable. It's what you're actually doing to or manipulating to create this cause and effect relationship in your design of the treatment effect. Okay, so let's kind of go to phase two then, if we're introducing this concept and talk about, why is this important? So why, that was the definition. If you recall kind of the practice problem that we had on blood clotting times for individuals getting drug A or B, then we had kind of this design where we randomly assigned folks into a treatment group where they got drug A, and then we observed their blood clotting times, and that was the first observation point. And then we randomly assigned another group of individuals to get drug B, so that's X sub B, and then we observed them and their blood clotting times, and that was our second observation point. For the sake of consistency, let's say we had n equals 10 going in here, and a separate group of 10 individuals, not the same individuals, going into the second row, which was getting drug B. Well, recall that your t statistic that we were calculating for the independent t-test was calculated as the x bar of group A minus the x bar of group B divided by this term that we call the standard error of the mean differences between group A and group B. And if you recall and you go back to the video on independent t-test practice problem, when we plug and chug this number here was for group A. The mean for group A was 8.75, and the mean for group B was 9.74, and the standard error, the mean difference term here, was 0.40. So when you plug and chug this, you get negative 2.475. Now, if you recall the general steps to null hypothesis significance testing, we were calling this our calculated t, and what we had to do was compare that to our critical t, and our critical t we had to look up from a t table, and it was based on t, and in this particular example at 0.05 we did it two-tailed, and our degrees of freedom or nu were 11. And when you look that up in the table, you get 2.201. So then we just set up the inequality where we say the absolute value of negative 2.475 is greater than our calculated t, so this is calc, is greater than critical t, which is 2.201. Therefore, our decision was to reject the null. So I've been doing all this really as by way of review. So I guess the point here is you're saying that drug A decreased, and I'll use this highlighted in red here, because the blood clotting time was lower for drug A than it was for drug B. So you're saying that drug A reduced blood clotting times, and that the mean of this, the mean difference from from group A or drug A to drug B is a statistical significant difference from 0. What does that mean? Let me just be clear here that remember the null here that we're testing against was that the mean of group A minus the mean of group B is equal to 0. Okay, so from a distribution standpoint, okay, we're kind of doing this t-distribution, and the t-distribution has a center point of 0, saying this t-distribution is testing the null, which is 0, so 0 is the center point, and we got a critical t that was, we're basically saying that anything more than 2.201, if you were to this side of the line, then we're going to challenge the tenability of the null that says these things could have a net effect of 0. Okay, so drug A decreased clotting time more than B, and it was statistically different from a mean difference of 0, because negative 2.475, the absolute value of that, was past this challenge line. And so the question that remains for us then is okay, so this is different from 0. It means what of the drugs had an effect. But what is the magnitude of this effect? Okay, so what did our t-test say? The t-test says the mean difference is statistically different from 0. In other words, this cannot be the case. We were to this side of the line, and we're challenging the fact that this could be the case. But we're left with the question is, now, here's the question. What is the magnitude of that difference? How different did it cause it to be from 0? How strong of a relationship is there between the effect of drug type and blood clotting times? And so this really is now what the effect size is going to answer for us. It's going to tell us the size or the magnitude of that treatment effect. And there's really two ways to do it. We'll leave them here in blue. So the two kind of popular forms of effect size for t-test. One is what we call the raw mean difference, and we're going to do a separate video just on raw mean difference. And then the second way of doing it, which will probably split out into 2 videos, is going to be the standardized mean difference. Okay, so just introducing the concept of the effect size right now, and then in the following videos we'll actually expand on this and do kind of some illustrations. Thanks for watching the video.